Okay, so in number 23 from 3.7, we'll use implicit differentiation. Take the derivative of both sides. That's because we can't separate y. We can't just solve for y, get all the cases, and then get an explicit function. So instead, we take the derivative of both sides with respect to x. And remember that the derivative of y is y prime. So the derivative with respect to x of y squared is 2y times y prime. And the derivative of e to the x squared is exactly that thing, e to the x squared, times the derivative of the exponent, 2x. And the derivative of 2x is just 2. So now we'll solve for y prime. Y prime is 2 times x e to the x squared plus 1. If I factor it out, divided by 2y. And so the 2's can cancel. And we're left with y prime, the first derivative, we could call that dy dx of x e to the x squared plus 1 divided by y. Now, however, we have to go find the second derivative. So the second derivative is simply the derivative of the first derivative. So that's the derivative with respect to x of the derivative with respect to x of y. That's the derivative of this half equals the derivative with respect to x of the right half, x e to the x squared plus 1 over y. So on the left, it's no big deal. The derivative of y with respect the derivative of y is y double prime, or the second derivative of x. Excuse me, the second derivative of y with respect to x. On the right-hand side, though, it looks like we have some quotient rules. So we have low, d high, and when we take the derivative of high, we need the product rule. F prime g plus f g prime e to the x squared times 2x. That's low d high minus high x e to the x squared plus 1 d low, and the derivative of y is y prime. So all of that over low squared, that's y squared. Now we'll clean up the top a little bit, and we'll say that the second derivative of y double prime, is y e to the x squared plus 2x squared y e to the x squared minus x e to the x squared plus 1 times y prime. But we already knew y prime from before, right here. So we'll substitute that y prime in there, x e to the x squared plus 1 over y. And then again, that's all over y squared. Instead of that, I'll just do 1 over y squared times all of that. Save myself from another denominator. So let's clean up what we have here. That's 1 over y squared times y e to the x squared plus 2x squared y e to the x squared minus x e to the x squared plus 1 squared all over y. So now that we have this, we can kind of combine our denominators, if you will. We'll take this buddy and distribute it across to the 3 terms and see if we can simplify a little bit, get 3 separate terms. Y over y squared would be just e to the x squared over y plus 2x squared e to the x squared over y. We both lost that y. Minus x e to the x squared plus 1 squared over y cubed. Okay, so that's how far I would simplify naturally. And then to match the back of the book, just to make sure that we're not off here. If you check the back, you see that's all over one common denominator of y cubed. So why don't we simplify that? They also don't have a big term squared here. So we think we'll probably have to FOIL that out, get a bunch of different terms. So if we were to FOIL that, that would be x squared e to the 2x squared plus 2xe to the x squared plus 1. That's just a simple FOIL of that term. And then these other guys, if we want a common denominator of y cubed, this one needs to be multiplied by y squared, and this one also. So let's see how that works out. Y squared e to the x squared plus y squared times 2x squared e to the x squared minus x squared e to the 2x squared plus would turn into minus when I distribute this minus through. Right, the minus has to distribute across these three terms. So that would be minus 2x e to the x squared minus 1 all over y cubed. And then it looks like the textbook factors out common factors from what it can, which isn't really everything. Let's see what they group together. E to the x squareds. That's here. There's 1, 2, 3 very clear e to the x squared terms. And no common numbers, so if we take out those e to the x squareds, we're left with y squared plus 2x squared y squared minus 2x. That matches the back. And they have these two terms just listed by themselves, minus x squared e to the 2x squared minus 1 all over y cubed. So there you have it, the second derivative of y with respect to x squared. Probably you were very close. It was just a matter of simplifying it to make it match. We did a couple tricks here. We got common denominators, FOILed the squared term, distributed the negative, and then factored it out just to make it match. Again, I would be happy with that term before we messed it all up there. We just had one single denominator, 3 different terms. That's perfectly valid.